So moving into angles, angles are a little trickier in the sense that there are equal leg angles and unequal leg angles. And they've got multiple insertion points. Let's go ahead and click this. So if you click angle, you just have access to the entire angle catalog all the way up to L9s. Anything bigger than that, you're probably going to want to use a bent plate. There are some shops that make sizes within their catalog bigger than this, but this catalog stops at L9. Under the for the subsets under the data file, the only thing here is like a filter. You can choose between equal leg and unequal leg, because right now this is both equal leg and unequal leg. If I go to equal leg, I'm only going to get things like L2 by 2, L2.5 by 2.5, L3 by 3. But if I come to unequal leg, I get things like L4 by 3, which is a kind of common, L5 by 3, and things like that. So these are the only unequal, or you can just see them all here under just angle. So let's go to equal leg, and let's pick something like an L4. So I'm going to choose an L4 by 4 by 3/8. Again, insertion point is user discretion. You choose where you think it's best to put it for you. I personally set this at different locations. Honestly, it just depends on how you're working with it. There are two locations that I use. I use the back corner whenever I'm using that as a work line for bracing, like for welded braces, I'll use this as a work line, or for columns, I'll use it as a work line. So that's my insertion point, is the back corner. I'll also use the center line location at the bottom, because again, what this does is it puts your center line location at the top, center, or bottom. Again, I stress that the center location for your center line, if I put it here, this is not the gauge line of the angle. So when you're inserting this as a brace, do not assume that the center line is on the gauge line. It's the midway point. So for an L4, the gauge line is 2¼ inches, and this midpoint is going to be at 2 inches. So don't. It's not a huge deal, but just don't assume that it is on the gauge line. All right, let's go ahead and put this in at the corner. And I have mine set to center. I want to set it to the bottom, because I want it to be on that bottom corner. My rotation angle is set to 0. I put it in, and I can flip my flange. Okay. If you change the rotation of this, it will change it around that center line, and it will just do a full sweep, 90, 180, and 270. And you'll notice that it's if you, depending on how you're looking at this, looking at it from the right side, like if I set it to 0, it's moving counterclockwise, like you would expect the cardinal directions in AutoCAD. But let's set this up as a column. Let's say we're using an angle column for a T-support or for a platform. So we're going to insert this as a column. Same thing, select line, select it. Okay. Again, what it's going to do is it's going to rotate around counterclockwise. So we pick 90, and it starts rotating to the left. 180, and it's going to go complete opposite of the what do you call it? I'm sorry, of the 0. This is kind of handy to get used to. So real quick, I'm just going to draw something like I'm going to put this at 4 inches and 4 inches. I'm going to go to the top view. I want this as a quick reference. This is something you might want to memorize for angles, because it'll help later on. I don't even know what my text size is set at. Probably pretty small. And we're going to put 270. Yeah, it's really small. And I'm in decimal, not architectural. But for the purposes of this, it's fine. Maybe put that at 3. There. So these are your angles. This is the angle for the rotation angles for your angle. Oops, just reset that UCS. Copy this over. I'm missing my command aliases on this installation, which is fine. All right, so here's your rotation angles. I'm actually using 2014, and man, do I miss the repeat DD edit. This got rid of in future versions. It when you edit it just closes out after you edit. It's kind of annoying. All right. So here's what your orientations will look like. So when I come in here and I put that column back in, I'll put it right here in the center. And I'll put that angle in at 0 on the corner. And I look at it from the top. Okay. You'll see right now I'm at a 0 degree. And then I go to a 90 and it looks like that. And I go to a 180 and it looks like that, and so on and so forth. The reason this is handy is because when you're building a platform, which I've seen a lot of platforms with angle legs, for like man platforms, valve axis platforms, things like that. What you're gonna want to what I do a lot is I'll just copy this, whatever it needs to be here, and then I'll copy this one up, and then I'll just go back in and change each one of these to their respective orientation so that they're all towing inward. I put that at 180. It's supposed to be 90. There we go, 180, because we're just going counterclockwise all around the circle here. And now each one of these is pointing inward, and I can build a platform based off of this. So, and there may be times where you have to do a flip flange, and you can do that. You know, sometimes you get options that you wouldn't otherwise have. It just depends on what your situation looks like. So that's for columns. Columns, I use that work line on the center, or on the corner, on the outside corner. When we're talking about bracing, I'm gonna put a wide flange in here. Oh, forgot. I got to use that line to create that vertical piece. Okay, and what I'm gonna do is draw a brace from the midpoint here. Do less than 45 and just bring it up. All right. Now, let's say I'm doing a welded connection. When I'm doing a welded connection, again, I'm going to keep it at the bottom corner, and I'm going to keep the center line location at the bottom. The difference being that I'm going to want to change the orientation because my brace is not going to want to be. I'm not going to want to have it towed upward like that. And I just realized I drew this at the wrong. I wasn't in the right UCS. There we go. Oops. None of my command aliases are set. It's all right. It's okay. 2D wireframe. Let's do that. Let's try this again. Midpoint less than 45. Much better. Okay. Draw this angle again. Now let's look at it. Realistic. Let's do conceptual. It might be a little easier to see what's going on with conceptual. Okay. Ugly, but you can see it easier. All right, you can see it's how it's towed upward. That's not how we're gonna have a brace angle look. So we want to rotate that 180 degrees. Now we've got something that is workable. At this point, you can either do a flip flange, which will flip the opposite direction if you needed to tow out separately to a different direction. You can do a flip flange. You can also rotate it 90 degrees, which will kind of do the same thing. It's just changing the rotation. So now that we've got it, angled the right way, we have it angled 180 degrees. This is where I would have the work line set if I was doing maybe a welded brace. Okay. But say I wanted to choose, or I wanted to do something, I wanted to do a bolted brace, like it's going to be a gusseted connection. I'm going to want to have that center line closer to where the gauge line would be. And it's close enough. It doesn't have to be on the gauge line. You can do that. It's more advanced. But you can get it close enough, which is fine for me. So I'm going to double click this, and I'm going to change the center line location to the center. And I'm also going to change the insertion to the center because I want them to match. Hit OK. And there we are. You can see that work line is in the center of that brace. So let's look at this thing from the front. Here's my angle coming in, and here is the center line is at the center of that brace, which is close to the gauge line. Not exactly there, but it's close enough. It gets the point across that it's going to be a bolted connection. So That's an instance where you would want to use the insertion and the centerline location not on the corner but in the middle. Same thing applies to horizontal braces. Let's say we have a horizontal brace. Oops, let's change this to top and top. There we go. Bring this down a bit. And let's say that we have a brace. I'm going to put a line here, change my UCS to world, draw a line here, less than 315 is fine. So we have a horizontal brace coming in here. I'm just going to use a quick example. Again, with the angle, I'm going to set that insertion point to this side and go to center and change it to 90. And now we're on top. We were previously at 180, we were on the side for the vertical brace. But now as a horizontal brace, by setting it to 90, our center line is centered on the brace, and on top of the brace, which now has a horizontal orientation. So that's where you'd want to set that insertion point and center line location to the side of the angle. So angles can be a little trickier. This is especially apparent when you're dealing with unequal legs. If I change this to something, so flip flange doesn't really matter too much when you're using equal legs. Flip flange matters a lot when you're talking about unequal legs. So let's change this from an equal leg to an unequal leg of something really dramatic like a 6x4. Or even a 6x3.5. No, we can't do that. Wait, we can 6x3.5 by 3/8. Something that's really dramatic. Okay. Now we have a long leg horizontal. Let's say we wanted to go long leg vertical. How would you accomplish this? Because as I rotate this, what's going to happen is, I can't go to 180 or I can't go to 270. It's going to turn up, right? We want to turn down. If I go 180, you could do this and it does turn down. However, it changes the properties because now my center line is on the side. We need my center line to be on the top. So the way to do this is to go 90, right? And see if we can do a flip flange on this. And it's probably not, because what's going to happen is it's going to want to flip the little flange up. So you have to find like a right balance for this. So the way to do this is probably go 270. There you go. 270 and you flip flange. Because 270 normally points up and now it wants to flip the little one down, little leg down. Go back to this. Turn my flip flange off. We were at 90, weren't we? Oh, we talked about wanting to go long leg vertically. That's a little difficult in some situations. So again, you kind of have to play with it. Even myself, like it's one of those things that's it's really hard to remember how things are going to work out. In this case, they actually won't let you do the opposite, which is go 3.5 to 6. But it's more apparent like when you're working with columns and stuff like that. But you'll have to play around with it to hopefully get the orientation that you're looking for. Because it is possible to get this thing to go vertical, but it's going to take some playing around. So that's where your flip flange is going to come into play, because it's going to come in handy to help with their unequal legs. So angles can be tricky, but over time you can get used to them. But you're going to use those for, like I said, for your columns, your horizontal braces, T support. Sometimes you have a small T support. You can use them in that manner. So I think that's it for angles. That's kind of the summation of everything involving angles.